Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on Cambridge IGCSE Maths Paper 4, which is the calculator paper for Specimen Paper B for exams from 2025. I'll be doing questions 11 to 20 in this part 2 of the video, and let's start. Question 11. Line L has the equation y equals 6x minus 1. A. Find the equation of the line parallel to line L that passes through the point 0, 3. Well, if a line is parallel to another, the gradient is the same. And the gradient is the coefficient of x. And here it's 6. So the gradient, or we can write as m, is equal to 6. And since it passes through 0, 3, we can write this is x, y. So we can substitute this into the line equation of y equals mx plus c. We have y, m, and x, and we can do that now. So 3 is equal to 0 times 6 plus c, and c is equal to 3. One more thing you could notice is a shortcut to find what c is because this point 0, 3 has x coordinate 0. So the y coordinate is going to be the y-intercept, which is the definition of c. So c is automatically 3 without needing to substitute anything. Both methods work either way, you get c is equal to 3, and the equation is y equals 6x plus 3. Part B, write down the gradient of a line perpendicular to line L. Well, if we have a gradient of a line perpendicular, and you multiply this gradient by the original one, the gradient of line L, we will get negative 1. So, this gradient multiplied by 6 is equal to minus 1. And this gradient, we just divide by 6 on both sides, and this will be minus 1 by 6. And that's our answer. Question 12. Find the integer values of x that satisfy the inequality minus 1 less than or equal to 4 minus 2x less than 8. Let's split this into two separate inequalities. So minus 1 less than or equal to 4 minus 2x, and 4 minus 2x is less than 8. So now we can bring this 4 to the other side to make this minus 5 less than or equal to 2x. Sorry, negative 2x. And on the right hand side, we get, bringing this 4 to the other side, minus 2x is less than 4. And now here we have a very important property. Now when we bring the minus 2 to the other side, to divide by minus 2, we have to flip the sign. That's because we are dividing by a negative number. Every time we divide by a negative number in inequality solving, we have to flip the sign. No matter if it's less than or equal to, now it becomes greater than or equal to. If it's less than, it becomes greater than. So minus 5 by minus 2, which is 5 by 2, is actually greater than or equal to x. And the next one is over here, minus 2x less than 4. So in a similar way, x is greater than 4 by minus 2, or negative 2. So now we have this, and we can write the whole inequality as minus 2 less than x less than or equal to 5 by 2. And the question is to find the integer values of x that satisfy the inequality. And so, we cannot write minus 2 because minus 2 is less than x. It's strictly less than, so it cannot be equal to minus 2. The next integer is minus 1. Then we have 0, 1, 2. But it stops at 2. Why? Because 5 by 2 is the upper bound, and that's 2.5 in decimal. So we cannot write a 3 because it's greater than the upper bound, 2.5. So it's only these 4 values here. You can write this in a set, by the way, so you can write it in set notation. Minus 1, 0, 1, 2. Inside curly braces. And that's our answer. Let's go to question 13. A, B, C, D, and E are all points on a circle. F, G is tangent to the circle at E. Find part A, angle EAC. Well, we can find what angle EAD is because we have angle ECD, which is 14, and EAD is subtended by the same chord as ECD, and that chord is ED. So they have the same common subtended chord, and therefore these angles are equal. So this is 14 degrees. Angle EAD is 14, and angle EAC is going to be equal to this 14 degrees plus the original 57 degrees of DAC. So 14 plus 57, which is equal to 71 degrees. Part B, angle ADC, this angle right here. Well, to find this is not very easy, but you need to visualize the alternate segment theorem inside this circle. How do we do that? We have the line FG, which is a tangent, and this angle, 34 degrees, is between a chord and the tangent, this angle. And this chord also forms an angle over here. It subtends an angle ACE. So this chord AE subtends this angle ACE. And this angle will therefore be the same as the angle subtended in the alternate segment, which is the segment outside this one. It is this huge segment over here. Just excluding this tiny portion where this angle is situated. Any angle inside this segment subtended by this chord is equal to 34 degrees. And therefore, that includes ACE, which is 34 degrees. Due to alternate segment theorem. And of course, the one above is common subtending chord. And now we have this angle 34, so this whole thing is going to be 48 degrees. And we have a triangle, so of course, these three angles add up to 180 degrees, and this angle we can find by doing angle ADC is equal to 180 minus the other two angles, 48 and 57. And that's simply 75 degrees, and that's our answer. Let's go to part C, angle ABC. This is a bit simpler than the other two parts, and we can see it's only 1 mark compared to the other 2 mark questions. So yeah, it should be very straightforward, and it is, because we have a cyclic quadrilateral here, and we just found this angle 75 degrees, which is opposite to angle ABC in this cyclic quadrilateral. And by the way, if you don't know where cyclic quadrilateral is, it is part of the circle geometry theorems. A cyclic quadrilateral is basically a quadrilateral formed by 4 points on the circumference of a circle. A, D, C, B are 4 points on the circumference, so it forms a cyclic quadrilateral. And opposite angles on a cyclic quadrilateral add up to 180 degrees. So you have 75 plus ABC is 180. So we can write that. And the reason, of course, is cyclic quadrilateral theorem. I'm just writing it in short form, cyclic quadrilateral, as quad theorem, but well, angle ABC is going to be anyway 105 degrees, which is our final answer. Let's go to question 14. Find the 3 inequalities that define this unshaded region R. So basically, these inequalities have to include this region. And how do we find 3 inequalities like that? We have 3 lines over here. I need to find the equation of each of these lines and then decide if greater than or less than symbol should be placed. Well, this line here, we can find the gradient, and we can take any 2 points. Let's say this point and this point. So we have 5, 6 and 0, 1. So it's y2 minus y1 by x2 minus x1. 6 minus 1 by 5 minus 0. So the gradient is 1. And the y-intercept, we can just look at the graph and see that it intersects the y-axis at y equals 1. So y is equal to x plus 1 is the first equation here. And what about this one? This is very straightforward. Because it's a vertical line, it is x equals k, where k is a constant. And what is k? Just look at the value where this line passes through the x-axis. That's x equals minus 4. So k is equal to minus 4. And this line is just x equals minus 4. Now what about the last line here? We can take any 2 points on this line as well to find the gradient. Let's take these 2 here. So we have 0, 2 and 4, 0. So the gradient for this is y2 minus y1, 0 minus 2 by x2 minus x1, 4 minus 0. That's minus half. And the y-intercept we can find by just looking at the graph. It intersects at y equals 2. So c is equal to 2. And therefore this line here is going to be y is equal to minus half x plus 2. And now that we know the line equations for all three lines, we just need to find the inequality symbol to put instead of the equal to signs. Well, the first one, x equals minus 4. With respect to this line, where is r? R is to the right of the line. And therefore, the x value is always greater than minus 4. But is it strictly greater than, or it can be equal to? If the line is straight without any dots, it's not a dotted line, it's just a straight line, then we have to include the equal to possibility. So in this case, it's not strictly greater than, it's just greater than or equal to minus 4. And let's take another example here with the dotted line, which is y equals x plus 1. This region R is above the line y is equal to x plus 1, and therefore you have to put a greater than or greater than equal to sign. If it's below, then you have to put a less than or less than or equal to. But here, this region R is above the line. And by the way, if you have y equals something, take above and below. If you have x equals something, then take left or right. For x equals, right is greater than or greater than or equal to, and left is less than or equal to. And for y equals, up is the positive, which is greater than or greater than or equal to, and down is less than or less than or equal to sign. So that's how you can remember the region. If it is in any of the directions, then you just use whichever sign corresponds to which direction, which I just said. Here it is above, and we have a dotted line, so in these two options we take the strictly greater than. And for the last one, which is this, it is a straight line and not dotted line, so it's one of these two. And because the region R is below this line, we can say that it is a less than or equal to sign. So y less than or equal to negative half x plus 2. And that'll be our answer. Let's go to question 15. F of x equals 2x squared minus 3x, g of x equals 7 plus 2x. A. Find part 1 g of minus 8. This is quite simple. We just substitute the value minus 8 is equal to x in this. So 7 plus 2 times minus 8, which is equal to minus 9. Part 2, gf of 5. That's basically going to be g of f of 5. So we do f of 5 first, which is 2 times 5 squared minus 3 times 5. And then we take g of that value. So it's 2 times 5 squared is going to be 50. 3 times 5 is 15. So we get 35. So g of 35, which is 7 plus 2 times 35, 77. That's our answer. And for part 3, g inverse of x. To find g inverse, first let's write y is equal to g of x to make things easier to write. And now, after you've written y equals 7 plus 2x, now we just swap it to make x the subject. So 2x is equal to y minus 7. X is equal to y minus 7 by 2. And therefore, this g inverse of x, we just write the same thing, right? Y minus 7 by 2. This is wrong. It's a very common mistake, but remember that this is the wrong answer. And the reason is, it is g inverse of x. So the variable in the right hand side has to be x. And therefore, we just replace the y back with an x here. And now this is the correct answer. X minus 7 over 2, and that'll be our answer. Part B, find f of x minus 6. Give your answer in ax squared plus bx plus c. We just substitute x minus 6 into x over here. So 2 times x minus 6 the whole squared minus 3 times x minus 6. And now we can expand the brackets. So 2 times x squared minus 12x plus 36 minus 3x plus 18. Why is it a plus? Because we are multiplying the whole negative 3 times each of these. So we multiply negative 3 times x, we get this. But if we multiply negative 3 times negative 6, two negatives become a positive. So plus 18. And by the way, if you're wondering how I factorize this that quickly, it's a simple formula. A minus b the whole squared is equal to a squared minus 2ab plus b squared. So we can see this is a squared or x squared. This is b squared, which is 6 squared 36. And this is negative sign and 2ab. So 2 times a, which is x, and b, which is 6. That's 2 times 6, 12, x, and we have a negative sign. And now we can expand this bracket as well, this large bracket here. 2x squared minus 24x plus 72 minus 3x plus 18. That's going to be equal to 2x squared minus 27x plus 90. And that is our answer. Let's go to part C. Use the quadratic formula to solve f of x minus 6 is equal to 0. Show all your working and give your answers correct to 2 decimal places. So f of x is just 2x squared minus 3x. And then we of course put a minus 6 outside this time. So that's equal to 0. And using the quadratic formula, we can write x is equal to minus b plus minus root of b squared minus 4ac by 2a. This formula you should remember by heart now. It's a very important formula in IGCSE. So 3 plus or minus root of minus 3 the whole squared minus 4 times 2 times minus 6 by 2 times 2. Remember that of course this 2 is a because it's the coefficient of x squared. B is equal to minus 3, and this 3 I wrote because it's minus b, and 2 negatives once again make a positive. But well, b is equal to minus 3, and yes, c is equal to minus 6. So, doing this, we get 3 plus or minus the square root of 57 by 4. And we can calculate this using our calculator. Doing that over here. Let's do 3 plus root 57 first. So take square root 57 plus 3 divide by 4. So the first value will be 2.64 to 2 decimal places. And what about the second one? Now we just do a negative of root 57. And of course now we add 3, divide by 4, we get minus 1.14 to 2 decimal places. And these will be our answers. So 2.64 or minus 1.14. And let's go to question 16. Question 16. Tina records the mass of each of 120 apples. The results are shown in the table here. Part A, calculate an estimate for the mean mass of the apples. Of course, for this, we have to find the midpoint of all of these classes which are given here, and these classes are mass in m grams. So the midpoint of the classes is just going to be the average of the smallest value and the largest value, or the smallest plus largest by 2 in each class. And this becomes 165, 200, then 245, and finally 285. So the mean mass will be equal to 165, which is the class midpoint, times the frequency, which is 18. And we add the value of the midpoint times the frequency for all of the 4 classes. And of course, once you're done with this, we divide the whole thing by the frequency total. And in this case, we have 120 apples. And if we add this, we'll also get 120. So either way, that's the total. And we just divide by that. And now we can simply use our calculator to get the answer. So let's get our calculator and do this calculation. So 165 times 18. Times 18, sorry, not 1. And then add 200 times 28. Plus 245 times 65. Plus 285 times 9. We get this value, divide by 120, and we get 225.5 grams as the estimate of the mean mass. And that's our answer. Now part B, draw a histogram to show the information in the table. In a histogram, we have to have the mass as grams and we need the frequency density. What does this frequency density mean? It's basically the frequency which is given over here divided by the width of each class. And in this case, the width means the largest minus the smallest value of each class. So here, 180 minus 150, the class width is 30. Well, let's just erase the midpoint so we have some space. So class width, otherwise CW, is 30 here. Then 220 minus 180 is 40. 270 minus 220 is 50. And 300 minus 270 is once again 30. And the frequency density, otherwise as FD, is the frequency F divided by the class width, which I've written as CW. So for the first one, for example, we have 18 divided by 30, which makes 0.6 as a frequency density. Then 28 divided by 40, that makes 0.7. 65 divided by 50 is 1.3. And 9 divided by 30 is 0.3. And now how do we draw the bars in a histogram? If you might have looked at any histograms, you might notice, of course, a histogram is a bar graph, but it looks much weirder because the bars have different widths. And this is precisely why they have different widths. The class width is different for each bar. And that's why we use frequency density. By dividing by class width, the bars will be shown in ratio to one another. Well, enough of that, let's just draw the graph. So for a class width from 150 to 180, we draw a bar which has a height of 0.6 in frequency density. So let's draw a line from 0.6 from 150 to 180. And of course, draw the lines down here, like this. So this is our first bar, and in a similar fashion, let's do a second one, which is 180 to 220 and goes to 0.7. So 0.7 will be in the middle of 0.6 and 0.8. So it goes somewhat like this. There we go. And just draw a line downwards. And same thing for the next one is till 1.3 from 220 to 270. So 1.3 is in the middle of 1.2 and 1.4. And of course this goes all the way till 270. And we just connect the lines. Notice that you can draw this line first and then draw the bars, or you can draw these two first and then connect them with the line. It doesn't matter, just the bar has to look like this. And the last one is 0.3 from 270 to 300, which is basically the end of the graph. So it goes from here and goes down. And this is our histogram. Of course, it's very good to just write down the frequency on top of each bar or inside each bar. So 18, 28, 65, 9. So well, that will be our answer. Go to part C. One of the 120 apples is picked at random. Find the probability that this apple has a mass of 180 grams or less. Let's go back to the table, and 180 grams or less is basically only this class over here. And that has a frequency of 18, so 18 apples are 180 grams or less in their mass. So the probability will be just 18 divided by 120. Part 2, two apples are picked at random from those with a mass greater than 180 grams. This is an initial condition. Find the probability that one of these apples has a mass greater than 270 grams and the other has a mass of 220 grams or less. So let's start with the first sentence. Mass greater than 180 grams is a preset condition. So out of these, the two apples are picked. How many apples have a mass greater than 180? We know that 18 have a mass less than 180. So greater than 180 will be the remaining. So we can either add this up or we can do 120 minus 18. It'll give the same answer, which is 102. And instead of picking two apples, let's say that we picked one apple first. We picked one and then we picked another. It's the same thing. We're picking two apples, just we're picking them separately. This makes it easier to understand the logic behind what I'm going to say next. So the probability that one of these apples has a mass greater than 270 grams. So let's assume that the first apple is greater than 270 grams. So this is our first case, and the number of apples which have a mass greater than 270 grams is just going to be this class here, which is 9 apples. So 9 out of a total of 102 is the probability for picking an apple with a mass greater than 270. So now we have picked one apple already and we need to pick the other one. But then because we have already picked one, we need to subtract 1 from 102. So there'll be 101 apples left. And the other apple has to be a mass of 220 grams or less, right? So we can go back to our table and we can see that out of those that are greater than 180, which ones are less than or equal to 220? It's only this class over here, right? And this class has 28 apples. So let's go there and write 28 by 101. And you can do this calculation or you can just leave it like this for now. And what about the case 2? This is where the other apple, which is the one with 220 grams or less, is chosen first. So the first apple is less than or equal to 220 grams. So this will be 28 out of 102 times 9 out of 101 because we picked 1 out of 28 of them and this is out of a total of 102. So we picked one apple, so of course we subtract 1 for the second one. And this one here is the one which is greater than 270 in this case. So we take 9 apples, we can take any one out of those 9 out of the total of 101. And so we have two cases done and the total probability, as well as total prob, that's going to be equal to the addition, the sum of these two. And to do this, we can first simplify the fractions. So we have 28 by 102 and we can divide these by 2. So get 14 by 51. And now this 9 by 51 here is divisible by 3. So you can cancel that as well. So 3 and 17. So we get 3 by 17 times 14 by 101. And over here, we can see that there are different fractions, but in reality, the numbers are the same. If we swap 9 and 28, we get the same fractions. And since we're multiplying, swapping is allowed. So we can just write this as 28 by 102 is 14 by 51. And in this 51 and this 9, we can cancel a 3, so 3 and 17. So in this case, it's just 14 by 17 times 3 by 101. So we get multiplying this, we get 42 on both. And 17 times 101 will be 1717. So 42 plus 42 is going to be 84. And the denominator is 1717. And that'll be our answer in simplest form. Let's go to question 17. The diagram shows the positions A, B, C, and D on the football pitch. A, show that the angle CAD is equal to 86.2 degrees to 1 decimal place. Well, we have 3 side lengths and we need to find one angle. So the best way to do this is using cosine rule. And here we need to find the angle, so we use the one which has cos A as the subject. That'll be equal to B squared plus C squared minus A squared by 2BC, where this is angle A. So this is side A, and B and C can be taken as these two, or you can write B here and C here, it doesn't matter. Either way, they're the two adjacent sides. So we get 18 squared plus 10 squared minus 20 squared by 2 times 18 times 10. And now A will just be the cos inverse of this value. And what is this value? Do that on a calculator. 18 squared plus 10 squared, which is 100, minus 20 squared, which is 400. So 24, and divide by 2 times 18 times 10. So that's just 360, and we divide by 360 here to get 0.066 dot dot dot. And cos inverse of this, make sure your calculator is in degree mode, and this angle CAD is going to be 86.177 dot dot dot, and to one decimal place it is 86.2 degrees. And since this is what we've asked to prove in the question, we have proven it, and this is our answer. Let's go to part 2. Calculate the obtuse angle ACB. Remember that it's obtuse angle. This is very important. You will see why later. First thing, we have two side lengths and one angle. So we can find the other angle here using our sine rule. So this time, let's erase out of this. This angle here, let's assume as A. This angle here, let's assume as B. Let's assume this is side B. Let's assume this is side A. Of course, we are just assuming this. This does not really matter. We just need it to substitute into our sine rule formula. So A by sine A is equal to B by sine B. And here, let's just substitute the values. 35 by sine of the angle which we want, which is angle ACB, is equal to the side length B, 18, by sine of 27. And now that means the sine of angle ACB, when you bring it here, so we'll cancel this and multiply by sine ACB, and we bring this fraction to the other side by flipping the fraction. 35 times sine 27 by 18, and angle ACB will be equal to sine inverse of this value, the value over here, just right there. And now we can do this in our calculator. So first, let's do sine 27, now times 35, divided by 18. We get this. And now let's take sine inverse of this, which is 61.977. We can write this as 62.0 degrees to one decimal place. And this is our answer, right? No, it's not our answer, because they've asked to give obtuse angle ACB. So this angle which we found is not obtuse. 62 is less than 90. But obtuse angle has to be between 90 and 180. So how do we bring it to that form? There is a special rule which you can use. Sine of any angle theta is always equal to sine of 180 minus that angle theta. In other words, if you have sine of angle ACB as the value we found here, that means ACB angle can be two different values within 0 to 360. So it can be either the angle we get over here, or it'll be 180 minus that angle. So the second angle here is just going to be 180 minus the first one. And therefore, the obtuse angle ACB is going to be equal to 180 minus 62.0. So to one decimal place, it'll be 118 degrees. Of course, you have to write 118.0 if you write to one decimal place. Or if you're writing to three significant figures, you can just write 118. Either way, we get 118, and that'll be our answer. Let's go to part C. Part C, a player runs directly from B to D in a time of 5.3 seconds. Calculate the average speed of the player in meters per second. Well, we need to find this dotted line which I've drawn over here, that length. And we know from the B part that this is 118 degrees, and we know from the A part that this is 86.2 degrees. So, also one more angle which we can find is this angle, because we have a triangle here and we have two angles. This is 27 degrees, this is 118 degrees. And we can find this because angles in a triangle add to 180. So angle CAB is equal to 180 minus the other two angles, which is 118 and 27, which gives 35 degrees. So this is 35, and the whole angle DAB, I'll tell you why we're finding this angle in just a minute. This angle is going to be 86.2 plus 35, which is going to be equal to 121.2 degrees. Now that we know this angle, we have two sides here and one angle, and this can be taken as the third side of this triangle. And we have the angle here, we have the two sides. We can use cosine rule to find this side length. So BD squared is equal to one side squared plus the other side squared, which is 35 squared plus 10 squared, minus 2 times the product of both sides, 35 and 10, times the cosine of the angle over here, which encloses between these two sides. So that angle is 121.2. And therefore, we can find BD squared using our calculator over here. So 35 squared plus 10 squared, which is 100, minus 2 times 35 times 10 times cos 21.2, 1325. And then we have 2 times 35 times 10, so that'll be minus 700 times cosine of 121.2. So let's do that. So cosine of 121.2 is that, and multiplied by 700, and we multiply by minus 1 as well, so we negate that, and we add 1325. So we get 1687.61 for the side length squared. Now what's the side length BD itself? That will be the square root of this value. So taking the square root, we get 41.08 continuous meters. So I just wrote to 2 decimal places. You can write to any accuracy up to 1 decimal place. And now to find the average speed of the player, which is the question, the average speed is equal to distance by time. And here the distance is going to be this value we found, 41.08 meters, and time is 5.3 seconds given in the question. So we do 41.08 divided by 5.3, and doing this we get 7.75 meters per second, 3 significant figures, and that'll be our answer. Let's move on to question number 18. Question 18. F is inversely proportional to the cube of g. When f equals 0.5, g is equal to 3. A, find f in terms of g. F is inversely proportional to the cube of 3. So f is directly proportional to 1 by the cube of g, so g cubed. Sorry, f is inversely proportional to the cube of g, not cube of 3. But yeah, this is our expression, and now we make this f is equal to k by g cubed, because that's what proportional means. F and g cubed, or at least f and 1 by g cubed, are related by a scalar, which is k. So when f is equal to 0.5, g is equal to 3. So 0.5 is equal to k by 3 cubed, which is 27, and k is equal to 13.5. So f is equal to 13.5 by g cubed, which is our answer. Now for part B, g is increased by 100%. Find the percentage change in f. So g is increased by 100%. G becomes g times 100 plus 100, because this is the increase, this is the original, divide by 100, because it is in percentage. So g becomes 2g. So when g becomes 2g, what's the change in f? So 13.5 by 2g the whole cubed is going to be f. And now that becomes 13.5 by 8g cubed. And okay, let's call this as f1, because this over here, 2g, let's call that g1. So we substitute g1 here, which is why we put 2g there, and cube it, so 8g cubed, and 13.5 in the numerator. So we can see that this can be written as 1 by 8 times 13.5 by g cubed. And this is f over here. F is equal to 13.5 by g cubed. So that's going to be equal to 1 by 8f. And that's f1. So the percentage change in f is going to be 1 by 8f minus f times 100%. And of course, we divide this by f because you only want a constant. So this will be negative 7 by 8f times 100% by f. So the f's cancel out. And negative 7 by 8 times 100 will of course be negative 87.5%. And that'll be our answer. Sorry if this looks a bit shabby working, but yeah, it does the job. Question 19. The area of a triangle is 12 meters squared, correct to the nearest square meter. The base is 5.7 meters, correct to the nearest 0.1. Calculate the smallest possible height of the triangle. So we can see that half BH is equal to the area of the triangle. And this area is going to be 12 to the nearest square meter is equal to half times the base, which is 5.7 times h. And well, to get the smallest possible height, because h in this case is going to be 12 by half times 5.7, if this is the exact value, but these are rounded values. So to get the smallest possible height, we need the smallest possible value of the numerator, so this is the lower bound, and divided by the largest possible value of the denominator, so this is the upper bound. So using the upper bound of 5.7 and lower bound of 12, so half times what's 5.7's upper bound to this specification, we divide the specification by 2, 0.05, and now because it's the upper bound, we add it to the original value, 5.75 times h is equal to, now the area is the nearest square meter, which is just 1, and divide 1 by 2, which is 0.5. And this 0.5, because we're calculating the lower bound, we just subtract instead of adding. So 12 minus 0.5 is 11.5. And now we can find h in meters. Let's use our calculator. Here we go. So 11.5 divided by 5.75 is equal to 2. And divide by half is the same as multiplying by 2, which is 4. So 4 meters is our answer, the smallest possible height of the triangle. Let's go to question 20. The diagram shows the frustum of a cone. The frustum has base radius 0.6 meters and vertical height 0.48 meters. The vertical height of the original cone is 1.44 meters. Calculate the total surface area of the frustum. Well, the total surface area will be the area of the smaller circle here, plus the area of the bigger circle, plus the area of the curved region around here. Let's find the areas of the circles first. We know this radius, but we need to find this one. How do we do that? Using similar triangles. It's not easy to see similar triangles here, but once we draw this line and draw this one as the radius, we can see two similar triangles form. This one and this large one here. So this length here is 1.44, and the length here we can find by doing 1.44 minus 0.48. So that'll be 0.96 meters. And this radius is 0.6. This one we need to find. So let's name that as r. So using ratios, so we need to find this by this, which is the smaller by larger, is equal to the smaller by larger of the radii. And therefore 0.96 by 1.44 is equal to r by 0.6. So to find r, we just multiply both sides by 0.6. This over here is going to be 2 by 3, and multiply by 0.6 is going to be 2 by 5, or 0.4 meters. And that's the radius over here. And now we can find the area of the two circles. So the area of the small circle is going to be equal to pi r squared, which is pi times 0.4 squared. In other words, 0.16. 0.16 pi. And the area of the larger circle is going to be equal to another pi r squared. Let's just write this as capital R because it's larger and it's different from the previous r. So it's pi times 0.6 squared, which is 0.36 pi. So we have these two things here, 0.16 pi and 0.36 pi as the areas here. Now what about this area of the curved region? That's going to be the area of the total curved surface area here for the big cone minus this small curved surface area for that cone around here. Well, the curved surface area of a cone is pi rl. We need to find L for both large and small cones. So let's write this as small l and the whole thing that's capital L. So now we can use Pythagoras to find both of these. So this is 0.96, this is 0.4. So we can say 0.4 squared plus 0.96 squared is equal to L squared. Using Pythagoras theorem, a squared plus b squared equals c squared, because this is a right angled triangle. And therefore, we can do this on our calculator. So 0.96 squared is that, and we get plus 0.4 squared. So we get this, and let's take a square root, which is 1.04. So L is 1.04 meters. Now we can do for capital L. So here we need to take the whole height and the larger radius. So we have 1.44 squared plus 0.6 squared is equal to capital L squared. Of course, there's one more way you can find L using this formula for the similar triangles. So you can do 0.96 by 1.44 is equal to this by this, and you would get the same answer as what I'm going to get here. So 1.44 squared plus 0.6 squared is equal to this, and square root to get 1.56. So L is equal to 1.56, capital L. And of course, that's in meters. So now, this pi r L for the small letters is going to be pi times 0.4 times 1.04, which is equal to 0.416 pi. And what about the capital letters? Pi capital R capital L is going to be equal to basically the curved surface area of the larger cone. That's pi times 0.6 times 1.56, and that's just 0.936 pi. So the curved surface area of the frustum is going to be equal to this minus 0.416 times pi. So there's going to be 0.52 pi. And therefore the total surface area, we can find it now because we have the area of both circles, which are up here, 0.16 pi, 0.36 pi. And we have the curved surface area. So adding these two together, we will get 1.04 pi. Adding all three together actually. But yes, 1.04 pi meters squared, and that'll be our final answer. And that's actually the final answer for this paper. That's the end. With that, I come to the end of the video. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.